السلام عليكم ورحمة الله وبركاته. أعزائي طلاب الصف السادس الثانوي. Today, inshallah, we will start the first lesson in our algebra service for this year. It is about the real functions. Definitions of the function: the relation between two sets x and y. X and y. Such that for each value of x, we have only one value of y. This case is called the domain, and y is called the codomain of the function. But what is the meaning of the real function? The function f from x to y is called real function if each of x and r is x and y is r. So it says number one, which of the following is a function on r given reason? Letter A, y equal x power 2 plus 3. Letter B, y power 2 equals x power 2 plus 9. The first rule, y equals x power 2 plus 3, is a function because for each value of x, we have only one value for y. But the second rule is not a function because for a value of x, we have two values of y. If we substitute about by x by 0 in this relation, so we get y power 2 equals 9 by taking the square root, the value of y equal positive or negative 3. And to check the relation is not a function. The relation is not a function if there exists at least one straight line parallel to y-axis and intersect the graph of the relation at more than one point. In the opposite figure, if we draw a vertical line for any place on the curve, it will intersect it at most one point, so this graph represents a function. But in this figure, if we draw a vertical line test, as you see, it intersects the curve at 2 points, so this is not a function. Example number one, which of the following is a function on R, which doesn't? This is not a function because if we draw a vertical line test, it will intersect the curve at 2 points. But this curve is represent a function because the vertical line test intersects the curve at 1 point. The opposite figure is not represent a function because if we draw a vertical line test intersect the curve at 2 positions, so it's not a function. Also, this curve is not a function because if we draw a vertical line test intersect the curve at the line segment from here to here, so it is not a function. You can deduce the domain and the range of the function from the graph as showing. The definition of the domain, it is the set of x coordinate of all the points that lays on the curve of the function, while the range is the set of y coordinate of all the points that lays on the curve of the function. So, example number 2, determine the domain and the range of each of the following functions. From this function, it is clear that the domain is -3 closed till infinity, different set of 0, and the range equals open interval -infinity to 4 open. This curve, its domain is open -4 till infinity, and its range closed interval from -3 to 2. Yes. The domain here is closed interval -2 and 2, while its range is a closed interval from -3 to 3. The domain of this figure is semi-closed -1 and 2, while the range is semi-closed -3 and 3. Exercise number 3 states the domain of the function f. This function is piecewise function. Then graph the function, and from the graph it to the range. Yes, the domain is the union of the two domains for each rows, -2, semi-closed, -2 and 0, union closed 0 till infinity. So the domain of this function is semi-closed, -2 till infinity. And to graph this function, construct a table like this, x and f of x. The first rule, we substitute about x by -2, -1, and 0 open. When we substitute about x by -2, -2 power 2 is 4, -1 is 3, -1 power 2 is 1, -1 is 0, 0 power 2 -1 is -1, and we can determine the position of this point, -2 and 3, -1 and 0, 0 and -1, and we put hole in it and join between the point. The second rule, that is x plus 1 at x more than 0, we substitute x by 0, 1, 2, and so on. When put x by 0, so f of x equals 1. Substitute x by 1, 2, 2 is 3. So we determine the position of this point and join between them. So this figure that is represent this function. And we can determine the range. It is open interval -1 till infinity. Identifying the domain of the real function algebraically. The polynomial function in the form f of x equal x naught plus x1 plus a1x plus a2x squared plus blah blah blah. This form is called polynomial function, and its domain is R or subset from R. The second type of functions is the rational functions. F of x equal g of x over h of x is a rational function, and each of g of x and h of x, each of them is a polynomial, so its domain is R different set of zeros of the denominator. Letter C, the nth root functions in the form nth root of h of x, where n belongs to z positive and h of x is a polynomial. So if n is odd number, then the domain is R. While if n is even number, then the domain it is the values of x that makes the function under the root is greater than or equal 0. State the domain of each functions. Letter A, f of x equal x power 3 minus 5x plus 12. Letter B, f of x equal x minus 3 over x power 2 minus 5x plus 6. Letter C, f of x equals root -2x plus 3. Letter D, f of x equal cubic root of 9 minus x power 2. The first function, its rule is a polynomial, so its domain is R. The second function is a rational function, so its domain is R different set of zeros as denominator, R different set of 2 and 3. Here the index of the root is even, so the domain, it is the values of x that is makes -2x plus 3 more than or equal 0. So -2x more than or equal -3, x less than or equal 3 over 2. So its domain is semi-open, -3 over 2. The index here is odd, so the domain is R. Thank you for listening, and I hope to see you next session, inshallah. Wassalamu alaikum wa rahmatullahi wa barakatuh.